Section 2.3, we're going to continue our discussion of derivatives. We're going to introduce two more rules that are not considered simple rules. And that doesn't mean they're complicated, but they are more complicated than the simple rules that we've already had so far. The first one we're going to talk about is called the product rule, and you've got quite a bit of space on your paper. It would be very, very nice, and let's admit it, it would be very, very nice if the product rule worked like the very first thing says. Question, does f prime of x times g prime of x, and then take the derivative of that, equal the derivative of each of the parts multiplied? I mean, that's what it would look like when we did, that's what it did look like for the sum and difference, right? Looked exactly like that. So it would be very, very friendly if this worked out to be true. So we're going to check it out, and we're going to do it with just an example. So the example we're going to use is 4x to the 9th for f of x, and x cubed for g of x. And the first thing we're going to do each side of this equation to check it out. We're going to multiply the two functions together. So we're going to take 4x to the 9th times x cubed, and we'll do the derivative in a minute. We're just going to multiply those together first. So what is 4x to the 9th times x cubed? 4x to the 12th. Yeah, we add the exponents together. 9 and 3 is 12. And now I want to take the derivative of this. So using simple rules that we did in the last section, what's the derivative of 4x to the 12th?
48x to the 11th.
Okay, is everybody good with that? So we're going to do it the other order now. So now what we're going to do is we're going to take 4x to the 9th, and we're going to take its derivative, and we're going to take x cubed, and we're going to take its derivative, and then we're going to multiply those two derivatives together. So what's the derivative of 4x to the 9th? 36x to the 8th. Very good. And what's the derivative of x cubed? 3x squared. Now I need to know what do I get when I multiply 36x to the 8th times 3x squared? 108. Some of you are good at multiplication. I didn't even hear any calculators clicking on that. Very good. How about the x? X to the 10th, and they are not equal. So unfortunately, the product rule is not simply take the derivative of each piece. So the question up here's answer is no. This doesn't work. This is not the product rule. The product rule does look different. So now let me show you what the product rule actually does look like. If I want the derivative of a product, what I have to do is I have to take the derivative of each piece of the product, right? So here's the g prime and here's the f prime. And you multiply it by the piece that it's not taking the derivative of as it was originally. Okay. So it's the first piece times the derivative of the second piece plus the derivative of the first piece times the second. And it doesn't really matter the order because this is addition and multiplication. So like I could switch around the f and the g prime. I could switch around the first piece before the addition and the second piece after the addition. It doesn't matter. And for those of you who have had some kind of calculus before, you may be more comfortable and used to doing it in a different order than I show it, or even in your book. It doesn't make any difference. You'll get the same answer in the end. It just might be a little bit different in the ordering in the middle. Okay? So we're going to do a couple of examples with the product rule. Before I go on, actually, let me just show you that this works for the example we did a minute ago, because I kind of was using that example to show you what didn't work before. So this was 4x to the 9th, and g of x was x cubed, thank you. And we had found that f prime of x was 36x to the 8th, and g prime of x was 3x squared. So if I follow this rule, it says I should take the original f of x function, that's 4x to the 9th, and I should multiply it by the derivative of g of x, that's 3x squared. Plus, now I should take the derivative of f prime of f of x, so that's the f prime, 36x to the 8th, and multiply that by the original of the g of x, which was x cubed. So we're just going to confirm this. This is not a proof by any stretch of the imagination. It's just an example to try to convince you that it's a reasonable assumption. Okay, it works for this one. All right, so 4x to the 9th times 3x squared is what? 12x to the 11th plus, what is 36x to the 8th times x cubed? 36x to the 11th. What happens when we add 12x to the 11th plus 36x to the 11th? Okay, was that what it was supposed to be? Whew, that's good. We didn't make a mistake. It really worked. So we're going to do some examples now. Now, let me make a comment on this one. If you really were given this original problem where you had 4x to the 9th times x cubed, and you were supposed to take its derivative of the multiplication of those two things together, you wouldn't use the product rule. It would be silly to do so. You would do it very much like we just did back over here, right here. You just multiply them, and you take their derivative. Are you guys with me? There would be no need to use the product rule. You'd have another way to do it that was simpler. But it does work. So if for some reason you felt the need to do something in a more complicated fashion, it would be okay. So, however, there are some problems that it is required. You have to use it for. This one right here is another one that you don't have to use the product rule on this. What could you do? Foil it or distribute it, multiply it out, right? You could do that, and then you could use simple rules. So this question could have lived, if you will, back in section 2.2. We don't need 2.3 methods to do it. We're going to use the 2.3 methods to get our practice, going for this one, and it's a really clean one to do it with, which is why I'm using it as the first one. So it's a good starting place. Okay? All right, so what the product rule says that I do is that I recognize that I have two pieces that I'm going to work with. In fact, let me do this for it. The pink piece and the blue piece. All right, so the first piece that I have underlined, and I always like to do it in this order because I feel like you can at least start. Okay, so the product rule says, at least one version of it says, I can just write down the first piece. I don't have to do any mathematics. I mean, really, writing something down is not math, right? All I did was rewrite. And then the part that's in blue, I need the derivative of that part. So what is the derivative of x squared minus 5? 2x. Nice. Product rule has addition between them, so there's my addition. And now I need to do things in reverse order. So I'm going to take the pink piece at the beginning now, and I'm going to do its derivative. So what's the derivative of the pink piece? Happens to be 2x as well. That's certainly not going to happen all the time. And then I need to rewrite the second piece, the piece that's in blue, identical to the way it is right now. So that's x squared minus 5. Okay, now you guys are going to be having a gateway coming up next week. I've alluded to that a couple of times, right? We talked about it a little bit last time, the fact that it's going to be happening. We didn't really talk about what it looks like. We talked about the fact that there's this ability to redo it. But here's something else to think about when you're thinking about or thinking towards that gateway. When you do the gateway, you don't simplify anything. So if you were doing this problem on the gateway, you would stop right there. Okay? Because the gateway's point is whether or not you understand how to take a derivative. It's not whether or not you're going to make a mistake with the algebra afterwards. You guys understand the difference in that? It's really hard in mathematics to separate out certain aspects of mathematics. So this is my attempt at trying to do some of that anyway. I want to make sure that you get the idea of derivatives on that gateway. However, on your homework, you are going to be simplifying things out. So we're going to clean this up. We're going to multiply things out and combine what we can. Okay, so that's our next step. So we're going to simplify this, we're going to simplify this, and figure out what we have. So if I distribute the 2x through the first terms, what do I have? 2x cubed, actually, and then plus 6x, good. And if I distribute through the second set of parentheses, what do I have? Good, 2x cubed minus 10x. And if I combine like terms, I get 4x cubed minus 4x. Correct? It's all good. And then I would be done. Okay. In this section of material, I have no way to make sure on WebAssign that you're really doing it this way, but when you do a quiz for me, when you do a test for me, if I'm asking you to use the product rule and you use some other kind of rule, that would be sort of like not following the directions, right? So please make sure that you're practicing that product rule as you do this material, even though in some cases you might not have to do the product rule. The point is to practice using it so that you can when you have to. This example does need the product rule. I can't simplify it with algebra or anything like that to do this problem. So we're going to do this one with the product rule. So what does the product rule say I need to do first? At least my version of it. X cubed. I'm going to rewrite the first piece. After that, I need the derivative of cosine x. And we did that last time. Does anybody remember what the derivative of cosine x is? Good, you guys even remember the negative. Excellent. Negative sine of x. And then we've got an addition sign for the product rule. Now, in the product rule, I need to go back and I need to reverse the order, right? So what's the derivative of x cubed? 3x squared. Fabulous. And then I rewrite the second piece, cosine of x. There's not a lot to clean up here, agreed? But we can sort of remove some parentheses, put the coefficients in front, clean up some negatives, things like that. So like the negative that's on the sine x can be in front, so it's negative x cubed sine x. And I can remove the parentheses off the second one. So this is 3x squared cosine of x. Any questions on that? Okay. Quotient rule. We're going to go through the quotient rule much like we did the product rule. It would be awfully nice if I could just take the quotient at the top, take the quotient at the bottom, and divide them. That would be wonderful. And so we're going to explore whether or not that works. We're going to use the same functions that we did before, 4x to the 9th and x cubed. And we're going to do them the left-hand side and the right-hand side. So the left-hand side says I should take 4x to the 9th divided by x cubed. And I should divide them first and then take the derivative second. So if I divide them, what is 4x to the 9th divided by x cubed? Yeah, 4x to the 6th. And what's the derivative of 4x to the 6th? 24x to the 5th. Very good. Now we're going to do it the other order on the second piece. So we're going to take the 4x to the 9th, and we're going to take its derivative. We're going to take the x cubed, and we're going to take its derivative, and then we're going to divide them. So what's the derivative of 4x to the 9th? Y'all remember it, 36x to the 8th, right? And the derivative of x cubed? 3x squared. And now we're going to simplify this. 36x to the 8th divided by 3x squared. What does that give me? 12x to the 6th. And just like before, we do not get equal quantities. So, is this a correct statement? No. I can't just use quotient rule as I would like the sum and the difference rule. This doesn't work. So we're going to try it properly now. This is actually the quotient rule. The numerator should kind of feel a little bit familiar, does it? It looks a little bit like the product rule. The way that it is currently written compared to the way that I wrote the product rule, it's kind of switched, right? The order is backwards of it. And the order does matter on this one because there's a subtraction sign on top, right? Like if you subtract 5 minus 2 or you subtract 2 minus 5, you get something different. So you do need to be aware that the ordering this one matters. And then we have the denominator squared as our new denominator. All right, so let me just take from, I'll come back here in a second. I'm just going to copy this down from before. I have extra stuff, but that's okay. All right, these were the individual quantities that we had when we were looking at the product rule. So I'm just going to show you that it really does work with this particular example. And what this says I need to do is I need to take g of x, that's 3x squared. So I should have left this down here, I guess. 3x squared times f prime of x I'm sorry. Let me get my stuff all in order. G of x, not g prime of x to start with. So x cubed. G of x cubed times f prime of x. That's the 36 x to the 8th. Minus f of x, which is 4x to the 9th. Times g prime of x, which was 3x squared. And this is supposed to be all over g of x, which was x cubed, squared. We've got a lot of x's in here that we get to clean up pretty quickly. So 36x to the 8th times x cubed is what? 36x to the what? Yeah, x to the 11th, good. And then 4x to the 9th times 3x squared is what? 12x to the 11th. And this is all divided by x to what power? 6th. Careful, right? 6th, not 5th, 6th. And then if I subtract, I can actually subtract that numerator because it's the same exponents on x. 36 minus 12 would be 24x to the 11th. So what is 24x to the 11th over x to the 6th? 24x to the 5th. And that should be what we said it was in the previous slide, was it? Oh, good. Oh, good. It worked. Okay, so now let's do one that actually needs it. This problem needs the quotient rule. We don't have an option. There is no other thing we can do. That's not exactly true. There is something else we could do. We could turn it into a product rule, but it would be messy to do that way too. But we can't use simple rules. That's not an option. So we're going to take this one. We're going to use the quotient rule. So the quotient rule says we're going to rewrite, the first piece is to write down the denominator. Okay, the denominator is the first piece. And I'm going to give you an acronym to remember this in just a moment. The denominator, 5t minus 3. And we're going to multiply that by the derivative of the numerator. So what is the derivative of this numerator? 2t, right? And we subtract. Now I do it in reverse. I need to multiply by the numerator, t squared plus 4, times the derivative of the denominator. And what's the derivative of this denominator? Somebody said it. 5, right? And this is over the denominator squared. All right, very good. And now we're going to simplify. So 5t times 2t would be 10t squared. And then I have negative 6t. I'm going to be distributing both the 5 and the negative through here. So I have negative 5t squared minus 20. Good. All over 5t minus 3 squared. There's one thing I can combine on top, right? The t squared terms. So 10t squared and negative 5t squared would be 5t squared minus the 6t minus 20. And this is all over 5t minus 3 quantity squared. So a couple things. This right here is how you can leave it on the gateway. You don't have to simplify anything. No chance of errors. If you do simplify something on the gateway, I will make sure you simplified it right. And if you make an error in the simplification, you will get the problem wrong. Okay? So don't simplify, because you're basically making me do extra work. I gotta look all your stuff now. So I mean, like, we're gonna make sure it's right. So just don't simplify it, because that's really not the point of that assessment. Okay? So on this one, the last thing you should do, and we're not going to actually go through doing it, and I'll tell you why, but is you should make sure that the numerator doesn't factor in some way that would cancel out the denominator. Now, the fact is it can't, and I'll tell you how I know that just by looking. It's great that there's a 5t and a 5t here, which means I actually have that option. The problem's the 3. There's no way I could break 20 apart and get a factor of 3 to make this the same. And if it's not the same, then it doesn't help me to factor it. Make sense? Okay. All right, we're going to do another one of these. This one's got a little trig in it. Quotient rule. H of x is sine of x over x cubed. So, somebody tell me, walk me through, what am I going to do first? X cubed. I'm going to write the denominator. Oh, I keep telling you. You know what? Let me pause here and I'll tell you the acronym that I remember when I very, very first learned calculus. So some people will have learned this as high over low. My teacher taught it as high over ho, okay, because it sounds really cool when you actually write it down next. So it looks like this. When you take the derivative of this, it's ho-de high minus high-de ho all over ho-ho. And I think, well, this is showing my age. This right here is was from a very popular TV show back in the day. Does anybody, what was it? Home Improvement. Very good. Tim the Toolman Taylor. It was Mr. Feeney. Was it him that said it? Wilson. It was Wilson. You're right. Next door neighbor, Wilson. So this is how this is how it was taught to me, and I think that that's probably part of why. So this helps me, and so anytime I do a quotient rule, I think of this. I don't think of G's and X's and F of X's and denominators and numerators. I do this in my head. So whatever it takes to remember the ordering of it is fine with me. All right, so we have an x cubed. What will we have after x cubed? The derivative of sine, which is cosine of x. Very good. What sign goes between this? Subtraction. Yeah, product rule has addition, but it's subtraction for the quotient rule. Excellent. Now we need to do the other ordering, right? So what's going to come next? Sine of x times 3x squared. Okay, it is important that that 3x squared is in parentheses sort of away from the x, because we don't want to think that we're going to multiply the x inside of sine times the 3x squared, because that's not a doable thing. Okay, and then what's the denominator going to be? X cubed squared, or x to the 6th. Okay, so we're going to simplify and clean up what we can. This is x cubed cosine of x minus 3x squared sine of x over x to the 6th. Now what? We can reduce, right? They all have x's in them, yeah? Here's an x cubed, a 3x squared, and x to the 6th. So how many of these divide out? X squared. So I'm left with x cosine of x minus 3 sine of x over x to the 4th. Okay. We have 4 more derivative rules to learn in this section. I have no idea why they're in this section in particular. Like, they would have fit in the last section just fine, but they're in here, so we're going to do them here. These are the last 4 of the 6 trig functions. We did sine and cosine last time, right? So these are the other 4. So does anybody from having a calculus class before remember any of these? Do you remember, Josh? What do you remember?
For tangent goes to secant squared x.
Very good. The nice thing about these is they kind of occur in pairs. These two, tangent and cotangents, derivatives are very, very similar. So tangent is secant squared, and cotangent is negative cosecant squared. And you'll find out as we do the next set too that the negatives only come into play when you're doing a derivative of a cofunction. Cosine's derivative was negative sine, right? Cotangent's derivative is negative cosecant. And if we're doing this one down here, we're going to get a negative down here as well. Okay. These are also in pairs. They're very similar in their derivative forms. Does anybody remember the derivative for either of those? Do you remember, Josh?
Secant x times tangent x.
Good memory. This is secant x, tangent x. So the derivative of secant is secant tangent. So can you guess what you think the cosecant might be? Cosecant is going to have a cosecant in it, you betcha. And cotangent, that's right. They're similar. Okay, so you guys ready to practice with one of these? Of course you are, because what else would we be doing? It's math class. Okay, so we've got one. H of x equals 1 over x minus 12 secant x. All right, so what are we going to do with the 1 over x? We've seen this happen in the last section. What would we need to do with it? Yeah, so it'll be x to the negative 1 minus 12 secant x. Again, there's no calculus in that yet, but it helps us to do the calculus if we do the rewriting algebra first. All right, so now what is the derivative of x to the negative 1? Negative x to the negative 2, good. And then now we need the derivative of 12 secant x. Well, the 12 stays. That's the constant multiplier rule we learned last time. What's the derivative of secant? Secant x tangent x. And the sign stays the same, right? Because it's the derivative of a non-co-function, right? It's not a co-function. There is a tiny little bit of simplification that really does need to be done on this one. Again, if you were doing the gateway that we're going to do next week, you'd leave that there. But the problem started out with 1 over x, right? So we can't have x to the negative 2 as part of our answer. How should we rewrite that? Yeah, negative 1 over x squared. And then the next piece is just fine. 12 secant x tangent x. Okay, the next one is the one that I'm changing something on, okay? So if you've printed these out, I need you to fix, oh, I didn't even, no, hang on. I think I got a copy paste in here in a funny way. Where's number 7? Okay, we did 5. I'm missing 6. Hang on a second. All right, all fixed. So we have the function sine of x times the cosine of x, and we're wanting to find the derivative of this. What do you notice? I mean, it's got trig in it, but what do you notice about it besides the trig? It's a product. It's the next one I have a change for you to make. Yeah, it's actually number 7. I was thinking we were headed there. It's a product rule. Don't just take the derivative of sine and multiply it by the derivative of cosine. This is a product rule. So this kind of combines the two pieces of information that are going on in this section, this trig stuff, with the product stuff. So we're going to take the derivative of this. What do I do for the product rule when I take the derivative? How do I start? I rewrite the first piece, sine of x. What will I multiply that by? The derivative of cosine, yeah, which is negative sine x. Good. Nice. And then product rule is addition, so we're going to put addition. What's going to come after my addition? Cosine of x times cosine of x. Okay, so what is the simplification we can do? There's just a tiny little bit. Yeah. Negative sine squared of x plus cosine squared of x. Let's just pretend for a minute that that said sine squared of x plus cosine squared of x. We would need to reduce that to 1. It's Pythagorean identity. Nope, this one won't be negative. Because the signs are different, we can't do anything any further. It is just like it is. There is something else that this can be rewritten as, but I think it's one of the double angle identities, but we're not going there. That's not where we're headed at all. But Pythagorean identities are basic enough that if when we see them, we will use them, okay? And we will see one before you know it. This is the one we're going to fix. At some point in the past, apparently I used this example, so I just thought, well, we'll just use it again. And then I looked thoroughly a little bit more at your textbook, and they don't have anything like that in there. So we're just changing it to something that looks a little bit more like what they do have. So just change that 3 over x to, say, 3x. Everything else is the same. Okay? 2 minus 3x over tangent x. All right, we're going to do a derivative. It is a quotient, though, this time, right? So where do I start? Yeah, the denominator, I rewrite it. Tangent of x. And what is it going to be multiplied by? Derivative of top, which is negative 3. And then I've got a subtraction sign. Now what? 2 minus 3x, right. Times? Oh, good. Secant squared x. And this will be divided by tangent of x squared, or tangent squared of x. Written that way is better. Gateway, you leave it right there. You don't do anything else, okay? But on your homework, we're working on all aspects of this problem, which includes the simplification. So we're going to simplify what we can, which is going to include distributing, and it's going to include very little after that. So you've got negative 3 tangent of x. I'm going to have negative 2 secant squared of x. I'm going to have positive 3x secant squared of x. And this is all over the tangent squared of x. If you're asked to do anything to simplify that, the only thing you could possibly try, and it may or may not lead to any better conclusion, would be to replace the signs, replace things with sines and cosines and see if simplification would happen. It might not. And so you're kind of at a 50-50 shot on that happening. So I'm fine with it being left like this, okay? One more problem. Okay, so on this one, my suggestion as we begin would be to actually distribute before we start with the 3. Okay, it'll make it a little bit cleaner. It's not terrible either way, but there's just no reason. So we've got 3 minus 3 sine x. That's my numerator. Now this one is going to have a little more simplification than the last one did once we get going, because the sines and cosines are a little bit easier to work with. All right, so we're going to rewrite the numerator first, 2 cosine of x, times the derivative. I think I just said it wrong. We're going to write the denominator first, and then we need that times the derivative of the numerator. So what's the derivative of 3 minus 3 sine x? Negative 3 cosine of x. Well, the derivative of sine is cosine, but this negative is already there. So the derivative of 3 at the beginning is 0, but the derivative that includes the negative 3 will stay negative 3. Yeah. All right, now I need to do it in the other order. So this is 3 minus 3 sine of x times the derivative of the denominator. What's the derivative of the denominator? Negative 2 sine of x, yeah. All of this will be over what? Will it be a 2? Or will it be a 4? It'll be a 4. We're actually multiplying the denominator, 2 cosine of x times 2 cosine of x. That gives me 4 cosine squared of x. Okay? All right, we're going to do a little cleanup. Finish this problem on out. We have negative 6 cosine squared of x. I'm going to go ahead and notice that there's a negative here and a negative here and cancel those to be positive. Be easier to keep track of my negatives through there because I'm going to be distributing both of them anyway. So now I just have 3 distributed to the 2 sine x, so that is negative 6, I'm not negative, positive. Positive 6 sine x. And then I have negative 3 sine x times 2 sine x, so that's negative 6 sine squared of x. And all of this is over 4 cosine squared of x. And here's the part where you have to recognize something. Do you see a sine squared and a cosine squared here? They have numbers in front of them, but they match, don't they? So in some sense, I could factor that number out in front. Whether you need to see this step or not is up to you. I don't necessarily need to see it, but reality is what I'm doing in my mind either way is I'm factoring out that negative 6. And I'm going to have a cosine squared plus a sine squared. I know I still have a plus 6 sine x. It's just not real helpful to factor that in this situation because the whole point is that I'm noticing that the part inside the parentheses is actually equal to, somebody help me out here. 1. Yeah, it's 1. So this is really just negative 6 plus 6 sine of x over 4 cosine squared of x. Do you notice one tiny little bitty more thing I can do? Yeah, not a 6, not a 4, 2. Well, they're at least all divisible by 2, right? So we're going to divide them all by 2. So this is going to be negative 3 plus 3 sine of x over 2 cosine squared of x for our final answer.